neuron sends signals from the dendrite end to the axon terminals where it goes to another neuron. All the action happens in the nodes of Ranvier, which is the membrane that is exposed, and ions can flow in and out of it. It's between the myelin sheath. So at resting potential, it has negative 70 millivolts. So the sodium channel and the potassium channel are closed. Most of the time, the neuron is at rest and no signals are passing through. The inside of the cell is more negative than the outside because of DNA and because there are more positive ions outside than inside. So there's less positive ions inside than out. So at resting potential, it has polarity. So it's where there's a negative side and then a positive side. So it takes work to maintain the polarity and the resting potential. Polarity is needed so that an action can pass through. What keeps polarity and resting potential is the sodium-potassium pump. It uses 75% of the cell's energy. And then when the leak channels actually, when they let sodium in and then some potassium out, it is always working because there's always leakings. So when it takes the sodium out again and the potassium back in, it does it in a ratio where it's 3 sodium out for every 2 potassium back in. So when the dendrites are stimulated, the threshold is met at negative 55 millivolts. So instead of negative 70, it goes to negative 55 millivolts, so it is slightly less polar. And this happens when some of the sodium goes into the cell. It is now slightly less polar and the threshold is met. When the threshold is met, depolarization occurs. So we'll get depolarization. Depolarization occurs. All the sodium flows into the cell super quickly, and that happens when the sodium channel is open. So the sodium channel is open, and all of the sodium goes into the cell. This is really quickly, and it is a passive action because no energy was needed. So now, instead of negative 55 millivolts, it goes to 30 millivolts. If I could get it, okay. So it went from a negative to a neutral and then a positive charge. So it makes the inside of the cell more positive because it is all the potassium and sodium ions are inside. When it is at 30 millivolts, it triggers the sodium channel to close. So the sodium channel closes, and it triggers the potassium channel to open. The potassium channel opens. This is called repolarization. So repolarization is occurring. So only the potassium channel is open. This action is passive because no energy is required and only the potassium is let out. So the potassium is let out because there was less outside than inside. So this happens really quickly, no energy needed. There we go. And that was the work of the potassium channel that only lets potassium outside. Now it's polarized again because there's a lot of positive outside, leaving the inside more negative. It even hyperpolarizes, going from negative 70 millivolts in the beginning in resting potential to now negative 80 millivolts after repolarization occurs. So now that potassium is outside and sodium is inside, it is at negative 80 millivolts. Everything is flipped to the opposite of what is needed. So all the sodium inside and all the potassium outside, it has to flip back to reset it in order for another signal to pass. So now it's going to go back to return to resting potential. So repolarization already occurred, and it goes back to return to resting potential. At this, the potassium pump, which let all the potassium outside of the cell, closes, and the sodium-potassium pump reopens to get the sodium outside and the potassium back in. So all the potassium is let in, and all the sodium is let out. This happens, really quickly, so that it returns to resting potential. At that point, it is no longer negative 80 millivolts. It is now at negative 70 millivolts. So now it is ready for another action potential to occur. Okay, it all happens really quickly, and this is just one node, so there is a lot happening throughout the axon. But in all, the sodium potassium pump never stops working because the leak channels are always letting sodium in and potassium out. But now it's returning to a resting potential and ready for another action potential to occur at negative 70 millivolts.